This video is going to be covering piecewise functions. Piecewise function basically refers to a function that is broken into pieces, and each piece being described by a different equation. We've been talking about absolute value. Absolute value, most basic, is y equals absolute value of x, and we can actually split absolute value of x into a piecewise function that represents each chunk of the graph. So if we think about absolute value of x from what we learned already, we got a graph that looks something like this. Okay, so if I am anything bigger than 0, I have the line with the equation y equals x. If I am x equals 0, I get x equals 0 out, or y equals 0 out. And if I look at the left side, it's the equation of the line y equals negative x. So we can write this, we lump them together to say that these three of these go together with these curly Q brackets, and however many equations it takes is what we put in there. And the right side here is looking at our x values, so our domain values, and what we see here represents the equation for that set of x values. So another example would be this function here. What this says is that from any value that is less than 0 for x is represented with the graph of 3 minus 4x. Once I get bigger than 0 and I plug in x equals 0, I'm using the line y equals 2x minus 1. So how we evaluate and how we graph is what we're going to look at here. Real briefly, how we would evaluate a function that's a piecewise. I'm just going to erase to give myself some space here. If I were to want to evaluate g of 3, that means I want to plug in 3 for x, and I'm going to use the equation where it falls in the domain. So if I look at this bottom here where x is greater than or equal to 0, 3 falls into this x is greater than or equal to 0. So I would use the equation 2x minus 1. So in this case I've got 2 times 3 minus 1 gives me 6 minus 1, which equals 5. So g of 3 is equal to 5. If I wanted to do g of negative 2, now that falls in the top domain set. So I'm going to do 3 minus 4 times negative 2, which is 3 plus 8, or 11. G of 0, now I need to look at which inequality includes 0. Again, that's the bottom because it has the or equal to with it. So I'm going to plug in 0 for x into that bottom equation. So I've got 2 times 0 minus 1 is negative 1. Okay, so to look at graphing these, and we'll do some evaluating as well. First we're going to sketch the boundaries. So we're going to look at what our x values are and so on, and then we're going to graph in between. So let's look at an example of what I mean by that. So my boundary in this case is x equals 0. Okay, so I'm actually going to plug in 0 into both of them to find the boundary values, and then I have to decide whether I use an open or a closed circle. So for the first one I'm going to use an open circle because it's not inclusive, and the bottom one I'm going to use a closed circle. So if I do 3 times 0, I get out 0. So I'm going to put an open circle at 0. And for the bottom one, x equals 0, I can't really plug in. It should be equal to negative 2, and that's going to be a closed circle. Okay, so from here, all the values that are bigger than 0 are represented by the equation y equals 3x. So I'm going to use only x values that are bigger than x. This is simply a line, so I could either just physically plug in a couple of x values bigger than 0 and get out my y's and then plot them, or from 0, 0, I can go up 1, 2, 3 and over 1 using my slope and do the same thing again. Okay, but the graph does not continue off to the left on this same graph because it's only for the x values bigger than 0. For the values smaller than 0, I'm going to use the equation y equals -2. So regardless of what x value is, as long as it's smaller than 0, I get out y equals -2. So I get a graph that looks something like this. It's broken up into pieces. Let's do one more. So I have y equals, or f of x, which is your function notation, is equal to 2x minus 1 for all values of x that are less than 0, and the line 2x plus 3 for all values of x that are greater than or equal to 0. So first I'm going to plug in 0 into both of them so I can get my boundaries. That one's going to have an open circle. This one's going to have an open, or closed, because we've got the line underneath it. So if I plug in 0 into the first one, I get the point 0, -1. And that has the open circle at it. And then if I plug in 0 into the top one, or bottom one here, I've got 0, 3. That has the closed circle. So now, for all values less than 0, that's over here, I'm going to graph the line 2x minus 1. Okay, so I want all the x values less than 0. So maybe I plug in -1 and -2. If I plug in -1, I got 2 times -1 is -2, minus 1 is -3. Then if I plug in -2, I get out -5. And again, I could have gotten this by, since I'm going to the left instead, to the right, going down 2 and to the left 1. Okay, then to the right, so all values bigger than 0 or equal to, I'm going to use the line y equals 2x plus 3. So I'm going to use values bigger than 0, so maybe I plug in 1 and 2. If I plug in 1, I get out 2 times 1 is 2, plus 3 is 5, and 7. So I get 1, 5, 2, 7. Again, what I could have just done is go up 2 and to the right 1. So I get a function that looks something like this. Okay, I want you to try number 3. All right, let's look at another one together. I'm going to have you try number 4. And then for number 5, let's try this one because now our boundary is a different value. It's 3. So I'm going to plug in 3 in for both of them. Figure out my open and closed circles. The top one's going to be open because it doesn't have the line underneath it. The bottom one's going to be closed. So if I plug in 3, I've got 4 over 3 times 3 over 1 minus 2. So that gives me 12 over 3 is 4, minus 2 is 2. So I'm going to plot the point 3, 2 and put an open circle there. We're going to pretend that's at 3. Let's try again. Okay, 3, 2. Sorry, it's a little hard on this little tiny thing. And then if I plug in 0 into, or 3 into the other one, I've got 4 minus 3 is 1. And that's going to be the closed circle. All right, so we need to get 3, 2, and 3, 1. There we go. All right, so now if I split this, for all the values smaller than 3, I'm going to use, so rather than trying to plug in 2, because 2 times 4/3 is a weird number, I'm going to use the fact that the slope is 4/3. So in order to just graph the line, typically we would go up 4 and to the right 3. In this case, I'm going to go down 4 and to the left 3. I'm just going to go the opposite. So since I'm going the opposite direction. So I'm going to go down 1, 2, 3, 4, 1, 2, 3. We're going to pretend that's straight. And then for the other side, all the values bigger than 3. The slope on this one is -1, and I can just treat it like I would normal since I'm going to the right. I'm going to go down 1 and to the right 1, and I get a graph that looks like this. All right. I want you to try number 6. We're going to do one more together, and the rest of them I want you to try for next class. So this one has 3 pieces. So we need to look at our entire domain here. So we've got everything that is bigger than 3. So I've got the point 3, 4 that I'm going to graph. Over here, I've got 2 endpoints. Okay, so I'm going to have to look at 2 points for that. Each endpoint, I've got -1, 1, and I've got 3, 1. There we go. And then this one here, if I plug in -1, I get out -3. So I've got open circle on the first one, 2 closed circles, and another open circle. So I've got the point 3, 4, open circle. I've got -1, 1, which is a closed circle. I've got the point 3, 1, which is also a closed circle. And then I've got the point -1, -3, which is an open circle. Alright, so I'm going to graph and connect. The middle is actually the easiest. You just connect the dots here in this case. Now for the others, since they're just y equals 4 and y equals -3, they're just horizontal lines in this case. So I get a graph that looks something like this. Try number 8. Number 9's a little bit more challenging because I've got this square root function in here. So it looks like I've got the point 2, 4 for one endpoint with an open circle at it. I've got to plug in -2 and +2. So if I plug in -2, I get out +2. And then same with this. So if I plug in 2, I get out 2. And again, both in this case are going to be closed circles. And I know absolute value does that. Okay, because it has a vertex at 0, 0. And then I have -2, 4 with an open circle. So I've got -2, 4. Now both of these are 4, which are just horizontal lines. We will practice this more in our next class.